So it says if measure of arc DG, which would be from here to here, is 45.6 degrees. What are the measure of angle E and F? Okay, I want you to notice that's two different angles there, angle E, angle F, but both angles are opening up to the same arc. So angle E intercepts the arc DG, angle F intercepts the arc DG. It doesn't matter where E and F are, just so long as they're intercepting this arc influences their measure. So I can see right off the bat that angle E and angle F are equal to each other because they're intercepting the same arc. The relationship between the arc and the angle is the arc is double the angle is half the arc. So if we're looking for the angle, the measure of angle E is simply going to be 1/2 times the measure of the arc, 45.6. So to get the answer here, I'm going to divide by 2. So the measure of angle E is half of that, which would be 22.8 degrees. I've already determined since angles E and F both intercept the same exact arc, they're going to be exactly equal to one another. So once I've already determined what angle E is, angle F has to be the same answer. So the measure of angle F is also 22.8 degrees. Don't feel obligated to do the work twice if you've already established the answers are the same. If you know the arc, you take half of it to get the angle. If it's an inscribed angle, if the vertex of the angle is on the edge of the circle. Just a heads up, your homework problems, some angles will be vertex will be at the center, so you have some central angles mixed in with some inscribed angles. You need to be able to determine between the two. This is the center, there's no angle happening there. That's the edge, there's angles happening there. Those are inscribed angles. Okay, example 2b. RT is a semicircle. What in the world does that mean? Half a circle. How many degrees in a whole circle? 360. 360. So in half a circle there is 180. So it says RT is a semicircle. That means from R to T this direction is 180. And from R to T this direction is 180. If you have a semicircle, then that's exactly half the circle. So whichever direction you go, if you go to the left or to the right, both sides are 180. It also means RT itself, the segment RT, is a diameter because it's going to go through the center. Okay? And it asks us for the measure of angle RST. Angle RST is this angle right here. RST intercepts arc RT, right? RT is an intercepted arc of angle RST. The angle should be half of the arc measure, so the measure of angle RST is 1/2 of 180 degrees, which is what? 90 degrees. The other thing that might happen in your homework tonight, and I'm not going to feel sad if it does because you guys should be able to handle it, that's a 90-degree angle, so now all of a sudden we have a right triangle in our picture, right? Suppose they gave you this exact same problem. It said RT is a semicircle. They also told you that RQ was 6.5, RS was 5. Let's suppose they gave you all that information. They said find ST. Okay? Well, if they said RT is a semicircle, we figured out this is a right angle. If that's the right angle, now we have a right triangle, right? RQ is a radius, QT is also a radius. That means this is 6.5 as well, right? All of a sudden, RT is 13. That's the whole length of RT. That's 5, that's a leg, that's a hypotenuse. Look for the other leg. So you can use Pythagorean theorem. Suppose it ended up that this angle here was, instead of that, let's say it was like, I don't know, let's say this was 47 degrees. Let's say it was that. And you got this, and they want to know maybe how big that side is. Well, now we got law of sine scenario where we got side angle. We use law of sine to find the missing angle, and then once we find some missing angles, then we can find, missing sides and so on and so forth. So again, they might relate back to stuff you've already learned with this new little property in here allowing you to find some measure you need to be able to do it. So keep that in mind, that just because all we're learning today for new examples is this property that this divided by 2 makes that, which I'm going to go back to what it really is, 90. or this times 2 equals that, either way. Know that anything you've learned up to this point could happen in these homework assignments. You might need this little fact here to get some more information to be able to do what you were able to do before. All right, so look for triangles, look for right triangles, all that type of stuff along with these new properties. Example C, 2C, measure of arc ABC is 180 degrees. Let's start with that fact. Remember, when an arc is named with 3 letters, that means you start at the first letter, you go through the second letter, and end up at the third letter. So ABC is this arc here. Which angle opens up to arc ABC? Angle D does, right? So, if arc ABC has a measure of 180 degrees, how big is angle D? 90 degrees. Okay, I'm going to erase my 180. We use similar logic for these other ones. Would everybody agree it says BCD is 242 degrees? BCD is 242. That means if I start at B, go through C, around to D, that's 242 degrees. So what angle can I find now?
B.
Angle AY. Starts here, right? Ends here, which is opening up. Angle A opens up to intercept that arc, right? So angle A is related to 242. How do we find A?
Half of 242.
Half of 242, which of course is 121. Okay. Now, the other 2 angles we need to find are C and B. Let's look at C first. Here's angle C right here. What does it open up to?
Angle A.
B, A,
D.
D, right? Okay, the angle starts at B, goes through A, ends up at D. How does BAD relate to BCD?
Divide A by 2.
Say it louder.
Divide angle A by 2.
No. How does arc BAD and arc BCD relate to one another? You're trying to answer you're trying to find the angle measure. How do they relate? Say again?
They make 360.
They make 360. They make a whole circle, right? I'm starting, BCD is 242, BAD is everything else, right? And a circle has 360 degrees in it, so I have the ability to find the measure of arc BAD by subtracting. So if I do 360 minus 242, I get 118 degrees. So BAD is 118 degrees, and I know that because these 2 arcs make 360. If you know one arc, the rest of the circle is the other arc that makes 360. So BCD is part of the circle, BAD is the rest of the circle, the 2 pieces make 360. And if I know BAD is 118, then I can find angle C by taking half of that, right? So 118 divided by 2 is equal to 59 degrees. Okay, now there's 2 ways to find angle B at this point. Let me demonstrate option A. All right, so option A is this. I know that ABC, all the way from here to there, is 180, right? So how long is it from A through D to C? Also 180. And just like we found angle C down here, this is 180, B is half of that, so B would be 90, right? Option B, once we knew the 3 blue angles, we had to find the 4th angle. A quadrilateral has 360 degrees in it, right? We've learned that before. So we just take 360 minus the 3 angles we did know, 121 minus 90 minus 59. That equals 90 as well. So that would work also. If you've already found 3 of the angles, you can subtract 360 to find the 4th. Or you can just find each arc, divide by 2 to get the angle measures. All right, so that's how you do that, measure of quadrilateral. So I would write my answers like this. Measure of angle A. Angle A is 121. Measure of angle B is 90. Measure of angle C is 59. Measure of angle D is 90. Anytime you get questions in an alphabetical sense, if you put your answers in alphabetical order, I really appreciate it. That's how I make my answer keys. It's kind of multiple things, alphabetical order for your answers is always a good plan.